This is video 48 on a MicroPython LVGL and embedded solution. When I read the comments from previous videos, I most often get asked to show how to build the firmware. So in this video, we build a new ESP32 firmware using Kevin Schlosser's GitHub LVGL MicroPython site. We will learn the steps to build the firmware for MicroPython 1.25 and LVGL 9.3. Please let us know in the comments with additional suggestions. Our test rig is based on an ESP32-S3-DevKitC-1 USB board connected to an ILI9341 display. The board has 8 megabytes of PS RAM. For this development effort, we use Ubuntu's 24.04 LTS for the build platform, which happens to have a suitable version of Python. By the way, I'm using a repurposed computer, so forgive the slow performance. As this channel covers multiple small system solutions over time, please subscribe to stay informed and click like, as that really helps. Our goal is to walk through the steps to build the firmware. Additionally, we want to verify the firmware by loading a simple example. We will introduce Kevin Schlosser's GitHub site, install the prerequisite software for the build environment, perform the build steps, deploy the firmware, and finally review a simple LVGL example in its configuration. The resulting firmware and a simple example files are at my GitHub site that is mentioned in this description and endnotes for this video. First, we have software we need to install. These items will help us get the software and follow the instructions. Oh, and we need this Python add-on. After we've installed that software, we can search for the GitHub MicroPython and LVGL. When you click on the search result, you should see this web page maintained by Kevin D. Schlosser and others. Okay, let's begin by opening a terminal. Let's navigate to the Documents folder. As you can see, I've put a playbook out in the Documents folder. We can follow along. First, we need to do an app update of our environment. Okay. Now we need to install Chromium browser, Git, and then this Python 3.12 virtual environment package. This software will allow us to get the software. As you can see, I've already done this, so let's open up the Chromium browser. Now we want to, in our search bar, we want to enter in GitHub, MicroPython, and LVGL and do a search. And when you do, you'll get many different links. And you want to go to the link that has KD Schlosser as the author. And that has the instructions that we're looking for. Okay, we're going to put that off to the side. Let's go through and look at what we've got here. So we have the instructions to do the Git, which we'll follow in a minute. We have a table of contents and specifically instructions for each, various different platforms. So we can go to the instructions for ESP32. When we do, you'll see that we need to install 4 additional packages: Build Essential, CMake, Ninja Build, and this Lib USB package. We already have Python on our system, but we can verify that by typing Python. You can see that we have 3.12 And most of these instructions require us to have Python 3.11 or higher. Now that we have all the prerequisites, let's follow the next step, which is to go back up in his website to do this git clone instruction. So I place that here as well. When you run that, it's going to fetch software from his site and create a folder called LVGL MicroPython. And you're going to want to CD into that. All right, let's follow the instructions. Next thing you see in his website is a list of supported displays. And fortunately for us, we see ILI 9341, that's our display. And a list of supported touchscreen. Fortunately, there's XPT2046, which we also are wanting to see. So let's continue through the build instructions. After we get past all these instructions for the different platforms, we come to command line syntax. So basically we want to run this single command, and that will build our environment. So as you can see, there's a lot of options that are passed to it. The first thing is the build target. So in our case, our build target is ESP32. Then there are build options. And in the case of the this package, the build option is clean. Well, we don't need to do that since we haven't built anything yet. Then there is the model variants. So there's a lot of variety here, especially around ESP32, around the board and the variants. And as you can see here, our particular board is ESP32_generic_S3, and then it has this variant, SPI_RAM_octal. So fortunately for us, that's supported by his software. So we scroll through and we look for the next instruction. So there's a lot of additional options that we could potentially do, but we're not going to need any of those for our default install. So keep going. He repeats the Python command that you need to do. Just keep on going. And finally, you come down to an example build command. Python 3 make py ESP32 board equals ESP32 generic S3. Board variant is SPI RAM oct. All right, this is great. This is almost exactly what we want to do, except for we don't want this display or this touchscreen. So we're going to copy this, put it in the screen, and then we'll modify and change those display and touchscreen. So we're going to enter in ILI 9341 and then the indev XPT2046. Okay, that's all we need to do. We can make this screen a little bit wider. So if you recall, we're in the Git folder right now, and so we can invoke this command. Now, this command is going to collect all the packages that we need, the MicroPython, the LVGL, the ESP32 software, and begin building it. And this will take a while, so I'll speed this up. Okay, the build is completed. I like to collect this last bit of information in the build and save it into a text file. All right, this has valuable information in case someone needs it around the build of the ESP32 firmware. Okay, if we look, there's a folder called build inside LVGL MicroPython. And inside that folder is two files. This is the bin firmware file, and there's a file that talks about the partitions. You can deploy this directly to your ESP32 device by connecting a USB cable, or you can copy this to another computer. I like to copy it to another computer. To do that, I install OpenSSH server, and then I like to get the IP address, and then I use FileZilla to connect and drag the file to Windows. Let's do all that. We'll bring up FileZilla. All right, let's connect to our system. Now you want to navigate to the folder in Documents, then LVGL, and then Build, and you'll see those two files that we saw a second ago, the bin file. So you want to take that file and drag it over to your host computer. All right, we've now installed it on our host. Let's close FileZilla, and let's bring up another package. In Thony, you'll see in the lower right-hand corner 3 burger dots. Click on those, and you'll see where it says Configure Interpreter. Click on that. We'll get a screen that looks like this. On it, you'll see Install. In the lower right-hand corner, you'll see 2 links, Install or Update or UF2. We want the Install or Update MicroPython, the ESP tool. So click on that. Look in the lower right-hand corner again. You'll see Cancel, Install, and then another mysterious box that has 3 lines in it. Click on that. And that's going to allow you to select the local MicroPython image. When you do, use it to select the image. Okay, when you select the image, it's going to appear in the ESP tool. And now you need to go to the target port, click on it, and select your device, which in this case is the USB single serial COM port 86. And you're going to want to click on the install on it. Now this is going to take a while. It's erasing the flash, and then it will connect to the device and start writing. Okay, the flashing is done. We can now close all these ESP tools of Thony. And we can click the red stop button. And now we see that we have MicroPython on our firmware. Now that it's deployed, let's verify that the modules work. We placed the ESP32 USB board in a test rig with the ILI9341 display. Now we need to connect the wires. Here's a picture of the ESP32-S3 module and its pins. Our ESP32 communicates with the display using the SPI wires. You can use any pins for the control wires. Here's what I used. Now that the rig is wired, let's configure the software to reflect the communications and the 2 devices. We can type help modules. When we do, we'll see all the special software that's been put on the system. It's got the display drivers, the 9341, and it's got the touchscreen, along with a lot of software for the LCD bus. Let's see how we use this. In our imports, we bring in the LCD bus, we bring in the 9341 display, and these init types, the touch screen, and then our software for LVGL, including the task handler, which we need for ESP32. Next, we define all the wire connections. Now we define the SPI bus. We tell it that we want to use host equals 1, which is actually SPI2. We provided the MOSI, MISO, and SEK. Next, we define the display bus by using the SPI bus above and giving it the DC and CS pins. Now we define the display. The display uses the display bus above. It uses the width and height, which is for 9341, it's 300 by 240. We provide it the reset pin. Now that we've defined our display and touchscreen, let's configure them. We're going to turn on the display, initialize it. We're going to set the rotation to 90, but in a little bit you'll see that we're going to want to use 0 the first time. Set the backlight, and then define the touchscreen. So you must, as you recall, when configuring LVGL, you must define the display, set its rotation, and then do the touchscreen, because the touchscreen is going to pick up the rotation from the display. And finally, you create the NDIV device. Now, the LCD bus includes a feature called Calibrate, which I'll go over in a minute. Next, we want to do the LVGL commands. And these are pretty simple. The label just says hello world. And the slider is just a large object across the center of the device. Okay, I've turned on the camera display so that we can see what it's doing. And let's start the program. Okay, when we do, we see the label that says hello world, and we see the slider. And we can use our stylus we can verify that the slider works. All right, as I mentioned, there's another feature called Calibrate. So let's go back to our program and turn that on. And we'll do that by first stopping the program. All right, to use the calibration, we need to go into our program and uncomment these lines, and further go up to display rotation and change the 90 to a 0. And in fact, I'll put 2 lines here. Okay, so we want to set the display rotation to 0 because the calibration program is written expecting the display to be at rotation 0. So we'll save that and run the program. So you can see the calibration program just ran, and that's because the ESP32 has not been calibrated, and so this program will run. We can force it to calibrate by just running the NDEV calibrate anytime, but you can see that it's automatic. Now what this wants is to display this red box, which it calls a circle, in the left-hand corner, and then the upper right-hand corner, and then the lower left-hand corner. So we must press this box 8 times in each of these locations. Okay, I will do that. And you can see it wants you to press and hold. Now that we've done the 8th press in the upper left-hand corner, it's gone to the upper right-hand corner, and we need to do the same thing. Now that it's completed the upper right-hand corner, it's put the red box, which it calls a circle, in the lower left-hand corner. We need to press it 8 times. Once we've done that, it's going to average them and produce these statistics. It's just going to display to you, and then it's going to save that onto the ESP32 device. And now the device is calibrated. And you see, it actually works pretty good, especially in this direction. I found, though, that it does, if you change the rotation back to 90, it doesn't work well at all. My recommendation is for you to not calibrate the device and just use it as is once you've loaded the firmware. But if you want to experiment with the calibration, now you understand how it works. Hopefully you see this example as your way to create beautiful LVGL graphics. In summary, in this video we demonstrated how to build the MicroPython firmware. We presented the test rig wiring, and we walked through a simple hello world configuration and tested the touch screen using the calibration feature. The benefit is that you can now create your own firmware at any time and continue with your MicroPython LVGL programming. Please comment if you feel other changes are needed. I hope this video helps your MicroPython LVGL programming. Thank you for listening.